Hello and welcome back to our data structures and algorithm series. In this video, we are going to implement the queue data structure operations using a Python list. So we want to begin by creating a class queue. Okay, so the class keyword is supposed to be all lowercase. That's why I have an error there. Then I'll just do tab to indent. Then we'll create the init function. So init going to receive self. Then here we can do self.list, which is the name of our queue. We're just calling it list. Then we want to define by default an empty list there. Then we can have the second method to check if the queue is empty. If the queue is empty, so we're going to do def, then we can call it is empty, like that. Then we can say return, and then self.list is equals to an empty list, like that. So if it's empty, it's going to return true, else it's going to return false. Then we also want to print items of the list of the queue. I'm talking about the queue here. So print queue item. So def, then you can call it print queue. Print queue. So here we can check if is empty. If it's empty, okay. Good. I didn't do the full colon there. So if is empty is not defined. Okay. Okay, so this is supposed to be self dot is empty. Then we do a full colon there. Okay. Okay. So here, if is empty, we want to print and say the list is empty. The queue is empty. That's otherwise we want to come out of the if statement and do a for. So for item in self.list, we want it to print the item. So this should be able to print all the items in the queue, which is actually a list. Okay, so we can actually come outside the class and create a queue of fruits, like creating fruit. So I can just call it, for example, fruits is equals to queue, just like that. And now I can do fruits dot print queue, like that. If I save and run my code, I expect to get the queue is empty. Good. So I have the queue is empty because indeed we've not added anything to this particular list. So let's do a method to do that. So here we want to do a method to add items at the end of the queue. So we know that the adding of items in a queue is called enqueue. So we can call this function enqueue. Okay, then in order to enqueue, we can do self.list, then use the append method. The append method, if you can remember, is used to the append method is used to add an item at the end of the list. So we are also going to pass the item that we want to add to the queue, and it's going to be saved in a variable called item. Then we call it like that. So that is it about the enqueue method. So we can try it out. Let's try out enqueue here. So add items to the queue. So we can do fruits.enqueue, and we can pass, for example, apple. We can also do fruits.enqueue and pass, for example, banana. Okay, then we can save, Control-Alt-N to run, and yes, our list has the first item as apple and banana. Maybe we can add oranges. Orange. Okay, save, run, and yes, so the first item, second item, third item. So you can see that they're actually organized in that way on the terminal here. Okay, so the next function should be to remove an item at the front of the queue. So here we're going to do def. That operation, of course, is called, as you guessed it, dequeue. So this one is just going to receive self. Then in order to remove something, there must be something. So we need to confirm if there is something. So if is empty, if self dot is empty, you want to check, is the queue empty? So if it's empty, we want to print the queue is empty. Then we just want to return, meaning we want to get out of this particular function. Else we want to remove, and to remove we do self dot list dot pop. So pop is used to remove items from the list, and you can pass it the index. So because we want to remove from the front, we know that that is index 0 in an array or a list, which is also index based. So we pass it 0 so that it can remove whatever is on the front of the queue. So that is how we implement the queue. That is how we implement the queue. It's that simple. It is that simple. Okay. Okay, so let's try it out. So let's remove an item from the front of the queue. So we can do fruits dot dequeue like that. Then we can save, So previously our list had apple, banana, and orange. Then we can print. So here we are printing items in the queue. Okay, so if I run the code, Control S to save, Control Alt N to run, you can indeed see that previously we had an apple, but now we've dequeued the apple, so we are only remaining with banana and orange. You can also, in the dequeue method, add a return statement so that it returns whatever has been dequeued in case you want to print whatever has been dequeued. So you can, for example, print, you can print here, print. So this method is going to return whatever item has been removed. So let's see, I'll be able to concatenate that. So removed. Okay. Save. Run. Okay. So we can see that now it's returning the apple. So we have removed the apple. So now the new list has only banana and orange. Okay. So so let me comment that for removing, and the next function we want to implement is the pick function. So return the item at the front of the queue. So we can do def, then we can call it pick self, and then here we simply need to return self.lists. Then you can just do index 0 here, 0. So if we save and we come and comment this here, then you can have fruits dot pick. So print item at the front of the queue. So save, run. Okay, I didn't get an output. Okay. Save again, run. Still no output, so let's troubleshoot the pick. Let's troubleshoot the pick function. Def pick. So return self.list. Okay. Okay, so so really, of course, it's returning to us the item at the front of the queue, which is the apple, but we are not doing anything with it. So we are supposed to print it here, so we can just do print like that. So if we save and run, we should now get an output, which is apple. Good. And which other function did we look at? In queue, the queue pick. We can also do the one for checking the size. So check the size of the queue. So def, and we can call it size self. Then we can simply return the length of self.list. Oh, something else I didn't mention here, on the peak, you are also supposed to perform the empty check. So I'll just copy this so that if the list is empty, we don't need to return anything. Okay, so just sort this. Good. So if the list is empty, that is very important. That case is very important. It should tell us that the list is empty. Otherwise, if we try to return something at index 0 and it's empty, then it will generate an error. So that's very important. The size of this one, it can just be as simple as you see it here. So if we comment this and we now do a comment for print the size of the queue, then you can do print foods dot size, the function, Control S to save, Control Alt N to run, and indeed our queue has 3 items. There's 3 items. Okay, there's one more operation that we learned during the theory. Let me just check it. I'm trying to remember it, but I cannot. Okay, so that actually is the is full operation. So we can also implement that very quickly. Okay. So to do that, we will need to change the init function so that we have a function, a variable max size for maximum size. So we can say self dot max size is equals to max size. So that's the maximum size. Then when we create the queue, we pass it the maximum size. So for example, 3. One way in which you can use this is inside the enqueue function here. So we can just do if the length of the list as it is, so self.list, if that length is equals to self.max size, and then we want to print the list is full. The list is not the list. Talking about the queue here. The queue is full. Then you can just do a return here. Otherwise, so the return will get out of the enqueue method without executing this line. So otherwise, this line is going to be executed, which is the one that is going to add a new item. So this should work. Let me just save this. Let's try and enqueue another fruits. Enqueue, let's say pineapple. Save, run. Good. So I expected to get that. The queue is full because we already have 3 items, and indeed I have it. So thank you so much for sticking to the end. That is it for this particular video. In the next video, we will look at how to implement these operations using a linked list. How to use a linked list to create a queue data structure. So thank you, and see you on the next video. Bye bye for now.